When we run regression models, typically we want to be able to take the model, in other words, the equation for the line of best fit, plug in a value, and try and make a prediction for what y might be. However, when we do that, we have to be careful that we don't use values of x that are very much outside the range of the x values that were used to get the model in the first place. Now, to illustrate that, let's have a look at this example. We're told here, okay, we have data for first marriage for men and women, and a model was calculated. It says results of a regression model for age at first marriage, and I assume this is the median age at first marriage for men against the year of the century for the years 1900 to 1940 are given. Okay, I don't have the data here, but if we were to run those in Minitab, we would find that the predicted age, a hat here, my predicted age, is equal to 25.7 minus 0.04 times the year of the century. And in this example, the year of the century is coded. So as an example, the year 1900 is 0, 1901 would be 1, 1940 would be 40, etc. So you'd plug in the year here, but the year would be a value from, say, 0 to 40 or whatever. Okay, so there's the equation for the line of best fit. The R squared is 92.6%, which looks pretty good, which means that almost 93% of the median predicted age at first marriage for men can be explained by the year of the century. In addition, the standard deviation of our residuals is roughly 0.24, which means that really when we plug our value in, it may be off by plus or minus 0.24 of a year, so about a quarter of a year. Now, the question here is, can we use the model to extrapolate and find the median age of first marriage for men in the year 2000? Now, the way our data are coded, if 1900 is the year 0, then the year 2000 will be the year 100. 100 in the difference between 1900 and 2000. So if I take 100 and plug it into this equation for year and solve for age, what will I get? And on the next slide it says if you plug 100 into that equation, you are going to get a predicted value for median age at first marriage for men to be 21.7 years. So almost 22 years is the median age at first marriage for men. It says here, in fact, by the year 2000, the median age at first marriage for men was almost 27 years. So what went wrong with our model? Well, anytime we do a regression, linear regression or any other kind of regression, we really need to have, first of all, a scatter plot to have a look at what the data really look like. In this particular example, we had data from 1900 to 1940, which puts me about right here. 1, 2, 3, 4, 5. 5 data points. Now, clearly, over that period of time, from 1900 to 1940, there was a clear trend here. And the trend was that median age was falling from 1900 to 1940. And what happened over that period of time? Well, hey, we had 2 world wars. Men rushed off and got married very early because, hey, once they went to war, they might not come back. And that trend continued roughly until about the 1960s. And then, hey, you know, psychedelic LSD and everything else happened, and since the 1960s, the trend has been in the reverse direction. So to come back to our extrapolation, we had data that ran from 1900 to 1940. That looked like a very strong negative linear relationship. We are asking ourselves, or trying to put the year 2000 into our model. Now 2000, the year 2000, is 60 years in the future from 1940. And this is an extreme example of what not to do with a regression model. You do not want to be putting in values of x that are much outside the range of the values you used to get the regression in the first place. So we had data from 1900 to 1940. I shouldn't be plugging in years that are much beyond 1940, and I shouldn't be plugging in years that are much earlier than the year 1900, because I don't know, when we don't know what happens to that relationship outside of those values of x. So just be careful in doing this. You really don't want to be plugging in values much outside, as I said, the range you use to get the data in the first place.